stand at the podium with
Yes?
my iPad and notes would click from the computer, but I don't have my clicker.
Do you want me to stand here and do
No. I can just sit here then.
You're good? No, I'm happy. Because I'm going to introduce you anyways, and I'm supposed to be your discussant.
I know. I'm looking forward to it.
No. We'll make something up good. But, so just, if you nod to me, then I'll just...
You want to do it?
See, I'm good.
You sure?
See, I'm going to still be here up here. I'll be fine.
Well, let me get the right slides up.
Because we want you to be how you're used to feeling better.
Well, I'm either
sitting
way.
Down is kind of...
I feel like it seems a little deflated.
See?
Like if you're sitting down. On the other hand, it's on one side of the room, whereas...
See, they all sit on that side.
Yeah, so... I don't know. I just looked up, I saw... From...
Yeah, of course. Yeah, how are you? So you're back? Yeah, I'm back. Cool. Now, where are you based now? Are you still in Phoenix? Not anymore. I mean, in São Paulo. Oh, okay, cool. Yeah, cool. Yeah, I was. I said to me after your presentation, I'm gonna ask. Of course. Oh yeah. No. I remember you really well. I think it was a lot of regression. Yeah. That's cool. Of course you did. That's great. That's cool. Yeah, that's it. Yeah, I mean, just having fun, working away. Things are good. No, it's really nice to see you. So you're here for 2 weeks? Cool. So you're doing both courses. That's great. That's really cool. How long have you been in Congratulations. I'm working in school. And now after this course, maybe I can eventually start teaching. Yeah, that's my thought. That's cool. That's cool. That's great. That's awesome. Very cool. This project that I'm going to talk about today has been a really fun project, really good. Yeah? Oh, good. Cool. Oh, thank you. Very good. December. Sorry. That's the one where I can't believe I had that. Okay, cool. All right, good.
me get the talk up on
Yes.
the thing here.
I think some people are going to be coming in.
Okay, so it's whatever you want to do in terms of when you want to get started.
No, I think we're good. I think Allison's going to be mad because I made her talk to a reporter. And she's like, I don't want to be late to guys' talk.
I talk to the reporters too. I even let them take my picture.
You did.
Well, you know, the only picture that's out there of me is pretty. I need to let there be more pictures to kind of dilute. Yeah.
Okay.
So I'm trying to. I still don't like it, but you know, yeah.
You're having to be more visible. Glauco is here now. Glauco, a gente já começa, acha que esperamos. Começa, ok. Ok. ¿Sí? Ok. ¿No está? A ver, let me just see what he's saying.
Yeah.
Guy, here's working.
Okay. I think I can just sit here. I mean,
No, I think you're fine. Go ahead.
all right.
Okay.
I may have to sit for my ankle or something.
See? So, but then you can switch over here.
Okay. All right.
Okay. So you just, I'm here, nod, I switch.
Yeah, okay.
And I'm with this little arrow, right?
Yeah. Let's see. Just push it once and see. Yeah.
Okay.
Perfect.
Good afternoon to everybody. Good afternoon. I'm here again to welcome you guys to the second late afternoon seminar of the 9th summer school. It's our pleasure of the summer school to be welcoming today Professor Guy Whitten from Texas A&M University. As many of you know, I wanted to start before we allow Guy to speak just by recognizing, we spoke a little bit about Guy's work and his contributions to the summer school in the opening ceremony, but now he gets to hear us and we get to make him a little bit embarrassed. But no, you shouldn't. But so Professor Guy Whitten, along with Bruno Cautres, as we mentioned in the opening ceremony, they hold kind of special, really special importance for the summer school, because from the first summer school in 2010, every year, no matter what, and we can say really, with Guy, we really can say no matter what, he has really been a part of the summer school. So he's taught every year since 2010. Now he's in his 9th year of the summer school. It's an incredible honor, but also because I think for those of you who haven't yet taken a course, and there's a couple of people here who have already taken courses since it's been so many years. I saw Rudy was saying he was in Guy's course when Guy was here teaching multiple regression in the first years of the summer school. There's lots of us who have taken courses with Guy in different periods. He stands out among scholars and among political methodologists for his commitment to teaching, his commitment to research transparency, his commitment to research and to advancing the discipline theoretically as well as in terms of the methods. And we're really honored to have such an important person for us in political methodology to be a part of our school and our senior faculty. And we're really always learning from Guy and really thankful because he's so generous with many of the faculty who teach, many of the students who teach. He's really one of those unique citizens in political science that I think needs to be recognized constantly and thanked as an example to all of us of the kind of intellectual leader you can be in the discipline. So I hope I made you embarrassed. But with that, in addition to everything, in the summer school, every time we have the luck that many of the incredible innovations that Guy has done in political science, they have been talks at the summer school. And so we get important, incredible moments for our discipline. Are part of them, we experience them in the lectures that Guy has given. And so Guy is going to be talking about a new project that this is actually, we've followed along as part of the summer school because it's been a couple of years that he's been sharing with us his work on the Dynamic Pi project. So with that, welcome Guy, and we're really looking forward to the Dynamic Pi project conversation this afternoon as part of the late afternoon seminar.
Well, thank you very much. Way too kind. I'd like to start off by thanking Daniela, Glauco, and Lorena for inviting me here again, and thanking these guys just do a fabulous job organizing this summer school. If you've never been to another summer school, then you don't have the comparison that I have. And these guys just, I mean, it's just an amazingly well-run summer school. I couldn't believe on the ride in today I saw like the road signs. I think that's a new thing. It's like they just keep thinking of new cool things to do. And I'd also like to thank everybody for coming out on a Friday afternoon. You've all had at least one hard week here, maybe two in some cases. And I know, this is a late Friday afternoon talk, so I'm impressed that you're all here. What I'm presenting today is this kind of overview of this big project where my co-authors and I are looking at the dynamics of different trade-off relationships. And this is a project that I pitched it actually to Laren Williams, who just finished teaching here when he was a graduate student. And I remember we had a lot of projects going on, and I didn't pitch it very well. And he said, yeah, I don't know, maybe that could work, I don't know. And then a couple years later, I just kind of let it go. I pitched it to Andy Phillips, who was just here, and Amanda Rutherford, another PhD student at the time. And the pitch was really disorganized, and these are some things that kind of connected. And they just bit into it and started finding all of this work that had been done in statistics and geology and lots of other fields that was along similar lines to what we were doing. And that's how this whole project took off. We're really excited about what we can do. Once you start looking at the world this way, you start seeing these type of trade-off relationships all over what we study. This is these dynamic compositional variables, why we call it a dynamic pi. I'll show you some figures that reflect that. But it's like a pie chart. So it's a composition that sums up, usually we think about it summing up to 100%. And it changes in interesting ways across time. And this is something that we have lots of these things, and we really hadn't done a very good job modeling them in the past. And so as a result of that, since we didn't have really good tools to analyze these things, we kind of changed our theories and the things that we did model in kind of ways that would work, but they weren't very well reflective of what's going on in the real world. And so that's what I want to talk about. But throughout this whole project, there's this moving back and forth between theory and method, and trying to make the movement between theory and method more reflective of what goes on in the real world. So if you could just, yeah. So this is when I was first starting thinking about this. I was doing a series of different models of dynamic data, and this first one is of party support in the United Kingdom, and we did what most people do, which is to model support for the party of the Prime Minister, and we're modeling it as a function of the economic circumstances and looking at how different groups' support for the party of the Prime Minister evolved over time. And then I had another unrelated project, which was political budgeting. This is one that actually, I think I presented a very early version of this at the summer school as well. And this is with Laren Williams, where we're modeling military spending as it moved over time. And so, okay, these are both dynamic data. And the thing, they're on very different phenomena, but the thing that they have in common is that we're modeling one component part of a dependent variable that's made up of more than two components. And so, in the United Kingdom, there's not just one party, a party of the Prime Minister, and then one opposition party. There's the party of the Prime Minister, and then there's all the other parties. And they're, depending on how you count, there's at least two other major parties. If you're living in Wales, you'd say there's three, or Scotland, you'd say that as well. In terms of a budget, we know that there's not just the military, right? The government spend money on lots of other things. And so by just focusing on one piece of the pie, you're able to do some interesting things and see some interesting patterns, but you're really you're kind of missing the bigger picture. And so this is a representation of kind of what you're doing. You're by focusing on one component as it moves across time, and implicitly what you're doing is you're lumping everything else together. And so in the UK example, you're lumping the Labour Party as the party of the Prime Minister, and then you're lumping the Conservatives and the Liberals together. In the military spending example, military spending is the orange piece of the pie, and everything else. And we know that governments don't work that way, right? And we know that party support doesn't work that way either. So, as an example from recent headlines, we saw in the aftermath of the Brexit vote that Marine Le Pen's polling numbers just surged. And of course, everybody was focused on that. Wow, could Marine Le Pen be the next president of France? But one of the things that they were paying a lot of attention to in the French media was, where did this surge, where did it come from? Did it come from the Republicans? Did it come from Macron and the socialists, or the socialists, right? Macron's sort of a socialist, whatever. We don't need to get into that. But if you go back, go forward, please. But what our modeling tools for these interesting dynamics were very limited. So what we want to do in this project is to model the whole pie and what's going on. Of course, because the pie sums to a whole, if you're thinking about public opinion, it's clear, right? The percentage of support, there's only 100 points of support out there. When you're thinking about budgets, it's a little bit more complicated because the pie can grow or shrink, and we can talk about that more. But there's certainly some trade-offs within the pie in both circumstances. And what we want to do is move to modeling all of the different component parts of the pie. And so once you start thinking about the world this way, if you could, you start seeing these things everywhere. There's support for parties, there's budget allocations, there's sources of revenue, there's issue attention, and then there's also inequality. There's a lot of pie-related variables there. And so what I'm going to talk about is kind of some of the methodological stuff, and then focus in mainly today on the work that we're doing on budget allocations and on inequality. So I got the next slide. We show this dynamic pie working group, which now, we got a lot of people who are kind of brought in as conspirators here. And of course, you see Lorena, you see a lot of people that are affiliated with the summer school or have been affiliated with the summer school. Jonica sitting right there. Natalia Barrera, who's at Texas A&M this year. Anyway, lots of people from the summer school that are working on this. And in Texas, we have a meeting every other week, and we kind of keep the people that aren't in Texas apprised about what we're up to by email, and we're just having a lot of fun. So kind of some nerd points here. well, I'm not going to read all this, but basically, what is a compositional time series? The idea is that each component varies between 0 and 1 at any point in time, and it sums to 1, of course, and there's this, compositional nature to it, and because of this compositional nature, we can't model the whole composition with regular regression tools. And there has been some political science work on these types of variables in the past, and this is an example from a paper that Gary King and Jonathan Katz published in the APSR in 1999. I think it's also a really good representation of why this stuff kind of fizzled out a little bit, because what we have is we have a simplex and a ternary plot, and these are, two-dimensional representations of three-dimensional spaces. I love statistical graphics, and I love complicated statistical graphics, but honestly, these things hurt my head when I try to figure them out. And I think that was true of a lot of the reviewers. And this work was done based on the work of a Scottish statistician, John Aitchison, who showed some of the basic breakthroughs of modeling compositional variables, and in particular this log transformation that I'll show you in just a second. But these tools that political scientists work with, the main limitations of them were that they couldn't go beyond 3 categories of a composition. That was the first thing, because think about what these graphs would look like if they were, trying to add a 4th dimension. You'd have to probably do something in color, and then let's say we go to 5 or 6, it quickly becomes, useless. And then basically these early analyses by political scientists were all cross-sectional, so they weren't able to look at things as they evolved over time. What we did is our initial modeling strategy is we used Aitchison's idea of the log transformation, and basically there's this one-to-one correspondence between the log transformation and the unlogged, and I can talk about that more if you want. And then we did some of the first really more complicated dynamic analyses of these types of variables. And our initial models were all error correction models, and basically we used a seemingly unrelated regressions estimation approach for this to estimate a system of equations, and you get just a ton of output. It's kind of like all the output, all the fun of a multinomial logit combined with an error correction model. And you just have all these numbers that are, they're meaningful, but they're really hard to interpret just eyeballing the numbers. And so right from the beginning, we wanted to build intuitive graphs that people could look at and figure out, what was going on in terms of these trade-off relationships. And so a couple more nerd slides, and then we'll get to some graphs, I promise. So this is the system of equations. Happy to talk about it. I think the bottom line is just how many parameters you end up with off of all of these equations. So we end up usually having to make a table for a paper that we publish on this, but we keep it in an appendix, and I don't think anybody ever really looks at them. Although, well, I can show you some if you want to see them, and we can talk about them more in Q&A. But just to, once we have those equations, basically we untransform it, so we exponentiate to get away from the logs, and then we do these graphical displays. And since we're looking at dynamics, we're doing these dynamic simulations where we keep everything the same and change only one independent variable and watch how the composition evolves as a result of that. And these dynamic compositional simulations, they're the same inferences that you would get if you did them, just calculating them by hand or by computer analytically. But the nice thing about these is that we get really nice graphs off the back end. So kind of a before and after picture that we have here, looking at the cats and king on the one hand, and then the type of inferences that we get on the other hand. And this is from one of the first tests that we did to see if what we were doing worked. And we did it on the same dependent variable that Katz and King were analyzing, which is support for the three major parties in the UK. And the graph that you see in color on the right is from this simulation based inference of, like, there was a jump in support for the Liberal Democrats leader. Obviously, that drives the Liberal Democrats up. But then the question is, whose expense does that come at? Does it come from the Conservatives or the Labour Party? And we can see the Conservatives' trajectories in blue, the Labour Party's in red. We see in the short run, both of the other main parties are hurt by this gain. But in the long run, Labour comes back to basically the same value, and it's the Conservatives who are hurt in the long run. So that's a new inference that we're able to get using this method that you couldn't get from the extant methods that people were using. Really important, I think, so no, that's fine. Okay. So this is the first paper that we did here, and that Laren and Amanda, I'm sorry, Andy and Amanda and I published. I do know them apart. And the first paper was in the AJPS about the tool, and the second paper is a Stata command that you can download as an ADO file, and we also published in the Stata journal for people to use the software. Really what we did isn't so much a new model, but we took a lot of existing tools that were out there and combined them in an innovative way. So I want to be careful, it's not like we made a new model. We just took things that other people had done and put them together and then packaged the software as well. And so that was the first work that we did. And then some of the extensions of things that we've done, the next thing that we did was we looked at changing attributes of the compositions of the compositional categories. So we looked at parties going in and out of government, and we thought we were going to do a lot of this, but that ended up being pretty complicated, and you can really only do a fairly limited amount of interactions in these unless you have a just tremendous amount of data. So we learned that. Then the next thing that we did was we tried some specifications that weren't error correction models, so other types of time series models. I know there's lots of people taking the time series modules here. And we also expanded the types of plots that we're using. So the next slide shows basically a set of graphs from that. And if you look at the graphs on the left are the original figures, like what we call a change from baseline scenario. And the graphs on the right are just summaries of the change in the long run from the graphs on the left. So basically, the same information is in the two top graphs and the two bottom graphs, but the graphs on the right side are summarizing it. And what we see is that in this example, we're looking at a government from the left and a government from the right in otherwise identical conditions, and there's a sudden surge in the degree to which their economies are integrated. And this is all in Europe, where we have the European Union integration going on. And we see that the party on the left, which is in the two upper figures, doesn't do much in response in terms of their budgeting behavior. But the party on the right does massive reactions to it. And I think you can see that from both the change of baseline figures, so comparing the top left and the bottom left, but I think you see it much more cleanly, and you get a better assessment of were these long-run changes statistically significant or not, comparing the upper right and the lower right figures. So that was kind of the big thing that came out of that particular project. So now, let's see. So where are we here?
Did I go fast, or was it?
Yeah, no, you're fine. You're fine. Oh, yeah, and then the other big thing that we did, I don't have a figure for it, is we extended this stuff from single time series to time series cross-sectional data. We even did like a spatial dynamic pi model, and that was fun, but it was a real challenge, and I'm not sure how much of that we're going to do going forward. It's not right on the front of what we're interested in. Okay, so talking about now moving to the projects in progress, so we've done a fair amount of comparative political budgeting. You saw that example with the European Union and the budgets. We're now expanding that in a number of different ways. We have a book project where we're looking at comparative political budgeting, and we've got a number of different modeling strategies for the size of pie. So thinking not only of how the composition is changing, but thinking about how the pie might be growing or shrinking and how that's going to play into there. And we can talk about that a little more. And then we also have what we call in that pie-to-pie modeling. And if we go to the next slide, I'll talk just briefly. These are kind of all the strategies that people have used in the past. They model, total revenues. They model the, one slice of the pie. This is like my paper with Laren. They do like there's Brenda and Drazen have looked at like total change, which I think is pretty interesting. There's the whole policy agendas group, which has looked at punctuated equilibrium theory. So what do the shape of the changes over time look like? And then, of course, we add ourselves to that. And so in this project, we're doing all of these things and kind of trying to look at them in a more holistic fashion. And this is the figure that's kind of the overview of the book project. And you can see we're thinking about it, as expenditures affecting revenues and revenues affecting expenditures, and all of these political and economic factors coming in and affecting both of the pies at the same time. And if you think about it, when you read a newspaper article or an article in like The Economist or something like that about debates over a budget and what is the government doing to try to address the current political and economic crises, this is exactly how they talk about it, right? They don't say, oh, well, let's just look at the one piece of the revenues or the one piece of the spending. They talk about it as a whole, in a holistic fashion. And so we're trying to move our modeling forward in a way that does that as well. I have a couple of preliminary slides from that. These models have a fair amount of interactions. This is just one of the models I picked out from the revenues. So we're looking at if you just switch from a left majority to a right majority, but you keep everything the same, how does that shift the revenues picture? And it's really interesting. What we're finding is like governments to the left rely a lot on goods and services taxes, which are really regressive. And this confirms some of the stuff that like Rueda and Barramundi have found. But we're able to not only look at that, but also look at, well, where do they trade off? And right governments actually increase property taxes and as they reduce goods and services taxes and increase non-tax revenue. And then the next one, we see much bigger effects for an ideological shift from a left majority to a right majority this time in terms of the budgeting. And this is mostly kind of what you would expect in terms of they're spending more, the right-wing government spending more on defense, less on public services. But then there's some other areas where thinking compositionally, maybe they're a little bit more surprising, like they actually do decrease spending on health, and the increase on recreation, I have no idea why that is. Our theory doesn't account for everything, but that's been a lot of fun. And then the thing that I want to talk about, the next thing I want to talk about is the work, which is really recent, that we've done on inequality. And so if you think about inequality, the classic figure that we've seen in recent years is these are the Piketty data, right? Where what does Piketty do, and Seiss and all of his co-authors, they've gone around the world and have collected these really long time series of the wealthiest people, and they've looked at wealth and income as a share of the total wealth or the total income in a country, and I mean, I think they've been incredibly successful, and they've found a lot of interesting things just looking at these trajectories over time, and people are just starting to model them. This is what I kind of found surprising, because I knew about Piketty and I knew about these findings, But they do surprisingly little modeling. And these are publications in top economics journals, but they're just showing us descriptive statistics, right? Showing the overtime trajectory of these things. And, sort of saying, well, it looks like it might be a factor caused by this. Certainly looks like the world wars played a role in this, but not really getting into estimating a lot of models on it. And of course, from our perspective, we want to run models, we want to test theories about this stuff, but we, of course, want to look at the whole pie. So if we go forward one, we can see this is a shorter time series, and to get the whole composition, you typically can't go as far back as we'd like to go, but this is the U.S. where we're able to go as much further back than most of the other countries we're working with so far. And the figure that we saw, we're looking at the top 5% instead of the top 1%, but they're kind of in the middle, and you can see them going up. Starting in the 1980s, they're kind of in the middle of the figure. But here we're looking at the whole pie as it evolves over time in the U.S. And so what we wanted to do was we wanted to test a theory about the impact of globalization on the income pie in a variety of different settings. And the extant theory that people have advanced about this is that globalization makes the rich richer. Okay, it may make everybody wealthier in a country as a whole, but that in terms of relative terms, that it's going to make the rich richer. And we thought, well, it's a little simplistic. Why would it always make the rich richer? And we can think of some circumstances where we think it might actually work in reverse. And not coincidentally, most of the studies that looked at the rich getting richer had done this in highly developed economies, and they've done it looking only at the impact on the top income group. So there's interesting questions there, like does it, when the rich get richer, who loses in relative terms? And then also, does it really work that way in every setting? And we made an argument that based on economic models of trade, so we're talking like Heckscher and Olin, that they propose that a country's imports and exports are determined by their factor endowments relative to the rest of the world. So your exports are going to come from sources of abundance, and your imports are going to come from sources of scarcity. And if we look around the world, not every country that's engaging in trade and thereby globalizing is rich in capital. There's a lot of countries, we're sitting in one right now, that's rich in labor, right, in terms of globally relative terms. And so we actually expect that you're going to see kind of the opposite trajectory. And to kind of, display that, the next figure, we take these diagrams. I love these diagrams by Carlos Blasch. And basically, you think about this hypothetical society where skills and wages are fairly normally distributed, and then you show this on as a cumulative density. So as we move from bottom to top, we're talking about wages increasing, and we move from left to right, we're talking about moving from the poorest people to the wealthiest, but keeping a cumulative density. And so moving to the next figure, the extant expectations, which we think only are going to hold for countries that are capital rich, are that the rich are going to get richer and the poor are going to get poorer. But we argue, going to the next figure, that in countries that are labor rich, that we're going to see the reverse. And so we set out to find data to test this. Our initial idea was that we would get a ton of data, because basically, if you think about who has these data, about the distribution of income in your country, any country that taxes, right? They're going to have data. The National Tax Authority has these data. I guarantee you they have them. Mm-hmm. They're better in some countries than in others. It's incredible how hard these data are to obtain. So that was kind of a smack. We thought we were going to have like all the countries of the world and really be able to do this in a big bad way. And I hope that we will eventually be able to. in the end, we ended up with 4 countries. So just quickly, we have a bunch of other variables in these models. I'm not expecting you to read this whole table. I've only talked about the first 2 rows of our theoretical expectations, but I can talk more about the other variables that we look at. But here are the 4 countries that we were able to look at. If you could go forward one. And so, the capital-rich countries are disproportionately represented. We have Canada, Sweden, and the United States. And the one country that is relatively labor-rich, at least in this small sample of convenience of cases, is Brazil. So, as you can see throughout this time, there's some movement between the capital-rich countries in terms of their capital to labor ratio, but the order of the kind of capital-rich countries on the top and the one labor-rich country that we have on the bottom doesn't change. So for our purposes, we're doing a very simplistic interaction and just running separate models on each country, looking at the impact of globalization, holding constant all those other factors, and then looking at the long-run effects on the relative income shares. And so if we go forward, we see the results from the U.S. And I don't know if you can see I think you can see the blue and the green, the circles versus the triangles. Really what we're focusing on is the long-run effects, because these are slow-moving relationships. And what we can see is that, as expected by us and by all of the literature, the rich do get richer when we have a globalization shock, increased globalization, holding everything else constant. But using our method, we're able to say, well, kind of where does that end? We've got the top 5%. They get massively wealthier in relative terms. The next group, though, is not different at all, the 80 to 94. And then going down, we see that that gain is coming disproportionately in relative terms at the expense of the middle. So the next 3, keep on that one for just a second. Yeah. And then the bottom group, who we kind of expected to really take the biggest hit in relative terms, doesn't actually. They do lose, but they don't lose a ton. All right. So going forward, here are the results for Canada. They look very much the same. A little bit different. Then if we go one more, in Sweden, we see exactly what we expected to see. The rich get richer in relative terms, and it comes a little bit out of the middle class, the middle income groups, but it really comes out of the bottom 2 income groups. And of course, I should have said, this is all pre-tax, because we wanted to get kind of a clean impact of globalization. And obviously, Sweden has a very, highly redistributive, very generous welfare state. So that some of that gap is probably getting made up in the tax and redistribution. And finally, if we look at Brazil, we see that mostly as expected, things are the reverse in Brazil from what they were in the capital-rich countries. So what we're seeing here is, in Brazil, the very wealthiest group, in this case the top 1%, their change is negative, but it's not statistically significant. So basically, we say they're unchanged from an increase in globalization. But the next group below them, so from 80 to 99, takes a pretty big hit in relative terms. And then the gains come for the middle, lower middle, and the bottom of the spectrum, exactly what we would expect given our theory about labor intensive or labor rich in relative factor terms economy. What would happen there? So we only 4 cases, so you got to be kind of careful about it. We have a revise and resubmit, and we did revise and resubmit it to PSRM. We're hoping we can get it published with just these 4, and that off the back of that, we would love to have a lot of people come forward and say, oh, I have those data on, Belize or Chile, wherever you have if you think you know of data like this, I want to hear from you. And that would be great. I guess our second hope is that on the back of this, we get a lot of interest in it, and we can get some grants to go out and collect it ourselves. I think you'd have to go to national tax authorities, which, depending on where you're going, that could be fun. But anyway, and then let's see, just a couple of other things that we're doing. With regard to income inequality, we've started to look at reversing the causal arrow. So one of the things in the U.S. that's been shown to really drive income inequality is polarization. So as we're in a period right now where all the polarization measures say that the Democrats and Republicans are really far apart, and that seems to drive income inequality. But you can easily flip that causal arrow around and say increased inequality would probably drive the gap between the political parties. So we've done some just very preliminary work where we've flipped that arrow around. This is just in the bottom, you can see the long run results, which we already saw for an increase in, well, no, we didn't actually see this. Increase in polarization in the U.S. looks a lot like the effects of an increase in globalization. So just looking at that bottom figure. But then in the next figure, we show what happens when we next slide, where we flip it around and we say, okay, well, let's say you have a shock, and this is in a VAR type setup, an increase in the wealth of the relative income of the top 5%. What does that do in terms of polarization? As you can see on the right figure, we see a statistically significant increase in polarization in the long run. So that's been kind of fun. Another kind of headache. And then the last thing, before I throw it up into Q&A, is we've started to write the second set of software commands to make all of these innovations that we've done since the first one accessible to other people, and we hope people will start to use this. And so if you look at the next slide, we've got a list of all the things that we're doing. So the first software that you can download right now, today, for free, is you have those change from baseline scenarios. The second software, which is currently being developed, Yu-Sun Jung, who's going to be the teaching assistant for the third week in the pooled time series course, and then Flavio Souza, who he's in Belo Horizonte, but he was TA in the first week, and he's been taking classes since, I think. They're the two main programmers on that, so you can talk to them, find out more about the horrors of working with me. But they're working on making the effects and ladder plots available and easy to create. Different scenario, of what we call evolving scenarios. So most of what we look at is the effect of a one-time change. And that kind of corresponds to what we estimate most of the time with our models when we get a coefficient. But you might be interested in a scenario where kind of like globalization just keeps increasing. And what does that look like? Lots of interactions, which we've obviously used. More flexible time series. The first one only does error correction models. And so we've obviously, in our own work, we've done some ADL models and other things. And then a battery of co-integration tests, because you got to test before you do an error correction model. That I'm sure you covered that this past week. And anyway, that's it. If we go one more. Thank you very much. What I'd say is dynamically interesting compositional variables are everywhere. We keep getting better time series data, and I think with these tools we can really address them. So, thank you.
There's water here if you want. So I left you some.
I'm good, thank you.
Okay. So I wanted to start by, before we open.
Oh, you're using my notes, okay.
I have, no.
I can type on this, that's fine.
No. I just have this.
I just like to keep track of what people say.
Yes. So you can go here.
Okay, yeah.
So before we open the floor to questions, as Guy mentioned, we were here this week in class. We're in the second week of the modeling dynamics time series in the summer school. And so there's lots of students that are here from the course. And I just I wanted as a first thing for us to think about a little bit in this kind of as where we left the class today and where you're taking us to kind of pose as a thought to discussions is we spend a lot of time, for people who aren't in time series, what do we spend a lot of time doing in time series is we start to be thinking about each of very complicated relationships, but how we start in the first week, we say, how does each variable behave and what are the characteristics of each variable, right? And so the first week we really are interested in just if we think about our explanatory variable. And then this second week where we were in time series is we started to say, okay, now let's think about a theory where I have just one explanatory variable that I'm trying to put together with one dependent variable. And where we left the students and where we got to where you said co-integration is we start to try to think about, do these two series move together across time? Or is there some other type of relationship and another type of model we need to try to think about? And the students at first who enroll in time series, I think it's a very frustrating experience because we say, I'm used to coming out of an econometrics course or a multiple regression course where I take theory and I have lots of variables in my model and it's very complicated and it's so easy to start thinking about interactive effects and all these great things going on in political science that I can start building into my multiple regression model. And in time series model, the experience we've had these last 2 weeks is like the first week, right? Only Y? What about X? Like, why 1 week on Y? Right? So the first week is a little bit of, I really need to get to know my Y, and now I understand my Y. And then this week, we start kind of, and it's very, reflecting a little bit on the students' experiences, we start thinking about, there's all these explanatory variables I want to put into you said theory, so I have all these great variables that I want to put into my model. And where we ended the course this week was we started to think about co-integration and thinking about, is X moving with Y? And a lot of what the students happened was they said, I have X, Y, Z. And when I tried to put X, Y, Z together, they don't work together, right? And so we ended up where we left the class off was, do I have to think more carefully and even giving up Z and have to go back and think of just about X and Y? So I wanted to pose kind of as a question is, where we left time series and where we left was, you have in time series, in very different from working with cross-sectional data, we have to spend a lot of time before we build very complex models. We have to be spending so much time to simplify and pare down relationships and be very, very simplistic and more synthetic in our theories before we can put in lots of variables. And so moving forward, kind of you're giving us an idea and thinking about kind of these dynamic compositional models, but I wondered if you could say a little bit, especially thinking about where the students are and where we left the students, right. About reacting a little bit to that feeling of how complex and how simple we need to think about modeling. Yeah. In general, I think if you have some comments and reactions about that. And then maybe the other thing that if we could talk a little bit about, which we didn't talk about so much in class, but as you talked about, there's so much here with endogeneity and in these models. And that's an area where I wanted to also raise, political science hasn't been as active in yet exploring as much as we could endogeneity in time series models. So what are the challenges in this context of doing that? So maybe if you could talk about that a little bit, I think it would be interesting to help reflect a little bit on.
Sure. Yeah. Well, yeah. There's a whole edition of the journal Political Analysis, which is the super nerd journal of political science. There's a whole special edition on error correction models and what we call equation balance, and it's this idea that if your variables are trending over time or in other ways not stationary, you're prone to do these spurious inferences. And so there are these kind of gotcha papers where people say, oh, look, these people ran these two variables together and they're not co-integrated. And you can find these kind of nonsense relationships out there because any things that are trending over time will look like they're correlated if you're not careful. And so the basics of knowing, doing the diagnostics of each individual variable that you put into your model, they don't go away, right? And they, the threats are there as you get into these more complicated models. The crazy thing that we had kind of added to that is that when you do that log ratio transformation, you sometimes find that you get different orders of integration from the variables going in and the variables coming out. And so when we first started doing that, I mean, the first thing we showed was like that figure of the liberals and the conservatives, and we were like, oh, it works. We got kind of a basic system that works, and we were super excited about that. And then we start getting into the diagnostics, and we knew because this is such a big issue in the analysis of time series, we knew that we were going to get hit with questions about error correction and equation balance. And so Andy and Amanda went to the political methodology, because PA, Political Analysis, is that journal published by that society. They went to their summer meetings and they presented a poster where they'd done all of these Monte Carlo simulations of different levels of stationarity of the different components of a composition, and then doing different log transformations. We took the approach of like, well, everything we're looking at is either integrated order 1 or order 0. So luckily, nothing that we had encountered in the empirical world was I2, so we're higher. So that meant we were sort of limited in the amount of the simulations that we needed to do. And what we're looking, because we're doing error correction models, we're differencing the variables, right? And so the threat is that you're over-differencing, which will basically induce autocorrelation on the back end of it. Well, autocorrelation is something we can test for. You learn that, in a basic regression course. And so we did all these scenarios where we had different orders of integration of the inputs before we did the log ratio transformations. And then we looked at the estimates on the back end and how autocorrelated they were and the circumstances under which they would be autocorrelated. And so that gave us kind of a basis for doing those same diagnostics with our real world data. And that's kind of the first step that we took on that, without getting, I could dive in a lot further, but in the second version of the software, we're taking a lot of these diagnostics and making them a canned part. And what it'll do is it'll give you a table of all of these different ways of estimating the co-integration relationships and seeing if it's valid. And that's always something that we check. So like with those inequality data, we did all those co-integration diagnostics. The other thing that we looked at was the error correction parameter. But it's not a formal test, but if it's a valid model, those parameters are all going to be negative and statistically different from 0, and they all were for the 4 countries that we looked at. Now we got some Uruguay data, but unfortunately they were post-tax, and so they're in our supplemental appendix, and they were a little bit noisier, and that some of those tests didn't hold for that, and so that the combination of the data not really being appropriate, for a comparison, kind of apples to apples comparison, and those tests made us say, well, let's put that in the supplemental appendix. But yeah, you definitely, the basic stuff doesn't go away. Now, turning to the thing about endogeneity, like from the very beginning, since we're doing a system of equations, we knew we were coming up against what's called a vector autoregression, VAR models. And if you look in political science, there's one paper I can think of that's kind of a substantive paper using VARs. It's a paper by Janet Bach-Steffensmeyer and one of her graduate students. Janet's at Ohio State. All of the other papers published in political science using VAR are about the technique. Here's this great technique. And the reason why that's true, I believe anyway, is political scientists hate models that are kind of letting the data speak. They always want to go from theory to model. And VARs were developed exactly in that way, as like, let's let the data speak. If Chris Sims, the professor, I don't know if he's still around, but he was at Princeton when he won the Nobel Prize for economics. He developed these models in reaction to, the whole Keynesian thing of all these messy systems of equations that weren't identified, and he said, let's just let the data talk to us. And I know you know those models, but that's something that political scientists just don't like. So that's why, we knew that was coming from the very beginning, and that was something that we could do, and we waited until we've already got some established papers and so on to even try that. The other thing has anybody seen a random forest model? These tree models? Yeah. That's another technique that I think we could really use a lot especially with survey data, to kind of validate our theoretically specified models.
Can you say a little bit more what is random forest model?
It basically partitions your data. You tell the computer what your dependent variable is and what all of your independent variables are, and then the computer starts searching. It just uses brute force to separate the data, and so it'll say independent variable 1, separates the data, values greater than 5 go this way, values less than 5 go here, and then it starts over again and just does a series of these binary splits. And what you end up with at the end is this is called a classification tree, and there's predicted values of the dependent variable, and you're just letting the data speak, right? And these are tools that hospitals use, the military uses them. If you have a little bit, there's a plane on the horizon, and you want to identify, or there's something flying on the horizon, you want to know what it is. With just a little data, you can use these things, and they love it. For predictive power, political scientists hate these things. They're well, it's atheoretical. You're just letting the data talk. Well. So.
Yes. Great. So let's see if maybe we can open the question, and if you can introduce yourself by saying your name and if you have a question after asking.
They're exhausted.
They're exhausted. Allison? Yes?
Allison Whitten, from Sydney in Mexico City. I was wondering, so I'm thinking about your dynamic pi, and Andy was pushing me.
Yeah, good.
When you've got to use dynamic pi, you can't use the Williams Whitten stuff. You use the Phillips.
I get paid either way, right?
I'm going to look into it, but I didn't want to put Laren into a fight with him. But how does your dynamic pi, do you assume that the total aggregate level stays the same? What if you have growth in the
Right.
total pi? How does that affect your model? Does it affect, can you control for it? So for example, total votes. So you could just think of voting. You can have over time, you have the Labor Party in Britain, but overall, over time, the electorate expands. So
Yeah.
as more people come into the electorate, that might be also having an impact on the distribution of votes across the party, independent of any other shocks that you're looking at.
Yep.
Or budget. It might be that with the economy growing, you just have more dollars or more pounds or euros or reais in the economy, and how might that overall be affecting the distribution between the sectors? Or you might have a recession.
Yep.
And how does that? So can your models deal with that fact, or do you have to assume that the aggregate total of units that you're examining and dividing into percentages stays the same?
Okay, yeah, no, it's an excellent question, and we're not the first people to worry about that. The geologists worry about it. The rocks get bigger and smaller. And the, no. I mean, it's a really good question, especially I think in the budgetary world, because we know that there's some things like that are entitlements, right? And those are harder to cut and more politically visible. Yeah, and I think we have theories that as the budget expands, you actually have more discretion, in an expansion than you have in a contraction, and so the standard approach that Aitchison and these other applied statisticians had used is they put size of pie as a right-hand side variable. Yeah. Well, no, I don't think it. Because with any variable that you just put on the right-hand side, you're essentially saying that the way what goes up goes down the same way. That it's and. No, you're not, because you're still, like, for any independent variable, it's like a multinomial logit, where for any independent variable that you have in the model, you get an estimated effect on the pairwise comparison the pairwise trade-off between any two categories of the DV. So that's not true, but there is this sort of, for any variable that you just regularly put in a regression, you're imposing the restriction that an increase that's reflexive, right? And so the way around that, of course, is to put it in an interaction for whether it's going up or going down, and then you get that parameterization for every trade-off. And we've just begun to do some of that. Now, the other thing that you can do is you can add another equation to your system of equations and allow the errors to be correlated across all these. And so you have one equation that's just the size of pi as the dependent variable. And we haven't played with that yet. That's complicated. But we're thinking about that. I know some people are thinking about that. Jonica is. And so to the extent that we've addressed it in the budgetary data, we're beginning to look at it interactively. So allowing the size of the budget going up to be different from the size of the budget going down. And then we can put in some things for, like, threshold shocks. Like, we tend to think like that, a recession versus, a substantial expansion so there's kind of to allow for nonlinearities within there. But yeah, you're absolutely right that it's a big issue. And this is the thing, like this project just, there's a lot of complications, but it's exciting because we're going to keep working on this. And size of pi is a big one that we're really interested in. In the context of the inequality, we have a problem. Well, we thought we were going to have a problem that we call the continuous pi problem, where you notice that we broke the income into segments, like top 1%, the next 15%, and then basically quintiles, so increments of 20%. But of course, you can break an income distribution into little groups of 1%, right? Any kind of theoretically. For right now, we've been limited by the data we can get, which for some reason, the countries whose tax authorities are publishing these data and making them available are doing it by quintile and then more fine breaks at the upper parts of the distribution. So, and you're always making assumptions with the way you formulate your dependent variables and your independent variables, and that's certainly true in this case.
Just one little thing. I think, though, that you might also think not just in terms of shocks, but have a little bit more flexible. Your shock implies something that happens in 1 year, a sudden change in pi.
Right.
But why not steep increase, like a period of years where it's steeper versus a shallower increase, versus or steep negative versus a shallow negative over a few more years' time? That might be something interesting.
Oh, I absolutely agree. And that's what we're talking about building in with the scenario-based simulations. So the reason why we started with a single variable changing is because it's analogous to what people know. And I think this is really important when you're trying to sell a new method and get people, not only publish papers on it, but get people interested in the method and get them to start using the method. Is you want to you're doing something different, but you don't want to do everything different. And so you want to tie it to things that people know. Well, what do people know? They know tables of regression results, right? And the parameters that they see in there, they know that's the estimated effect of a 1 unit increase in X on Y, right? Now, obviously, it gets more complicated, as you move forward in your basic econometrics book. But that's what we tried with those initial change from baseline and also the initial effects plots. So those are all a change in one independent variable. It's and we call them shocks just because the idea is you have the system running flat with everything at its mean, and then you change that one variable, and that's a shock to the system. And in the error correction, it plays out as you move over time. So, yes, please.
So I had two questions, one very general and one very specific. My name is Ryan.
Okay.
I'm a postdoc here at USP.
Thank you.
So first of all, very general. I was wondering if you could elaborate a little bit more on the extensions about cross-sectional and spatial stuff, and I think you mentioned that there were some problems. I was wondering, so what are the limitations there as well? This might just be because I'm seeing things through a spatial lens because I just took Laren's course on this.
Right. Yeah.
But yeah, I have a project that this seems like it would be a good fit for it, but it has a spatial element as well. So I wanted to know a little bit more about that.
Sure.
And second thing is, I'm very specific, but I was curious about this. I noticed that in the project in which you were doing there are 4 countries, Sweden, US, Canada, and Brazil. I noticed that you kept changing the top category. You had top 1% for some, top 5, top 10. I was wondering why that was, if there was some sort of data availability issue, what was going on there?
That's exactly what it was on the second one. It was the data availability, and we're the reviewers for the first round of reviews. Like they love the idea of moving beyond Piketty, right? Moving beyond just analyzing the top. They liked the theory about globalization, but they're like, oh, you need to get more countries, right? And they said the data are widely available. Not true. So we actually did a data map comparing sources of data, and there is this misperception. We had the misperception as well. Oh, these data are going to be easy because any tax authority, worth a darn, is going to have a good estimate of the income profile of their citizenry, and unfortunately, maybe we're missing something obvious, and if we are, I'll buy you dinner at the fanciest restaurant if you can tell me what we're missing. But like they said, Luxembourg income data or something like that. They're very scattershot in time, and globalization is something it's this long, slow-moving process, and so you really, to get at the effects of it, you want long time series of data. And I think that's true also about income distributions, that these are slow-moving processes. But even when you're moving like 1%, that's a huge effect on people's lives. Okay, I'm getting off on a tangent there. Now, the extensions to cross-sectional and spatial. The extension to doing like just straight up TSCS, right, is very straightforward, and you're not able to do like panel corrected standard errors. Okay. But you can, but that's fairly straightforward. The extensions to different kinds of spatial models are differently complicated. So I'm a big critic of the spatial autocorrelation model, so the SAR model, right, where basically this framework, which is by far the most commonly estimated spatial model in political science, and we've actually done some literature reviews to talk about that. And the reason why I'm critical of this is that it assumes in a time series perspective that the effects of your neighbors, so this is the effect of unit J on unit I, are immediate. And I don't believe that. I think that instead, like if we start putting, T subscripts on these things, I think that these effects should be at T-1. And at that point, it becomes a spatial X model, which is super easy to estimate, even with these compositional models. This model, this SAR, we knew, this is another case where we knew the reviewers were going to ask us to do it, but we thought we'd wait until we at least got an R&R. So we submitted initially as only spatial X, and I think I can't remember if we did, spatial error models are pretty easy too, to do in the context of the compositional models. That the SAR in that context is just a bear because you've got these spatial weights matrices connected to logged odds ratios, and it's just really hard to get it to estimate. That paper is coming out now, and we did do it, but yeah, I thought Andy was actually doing most of the programming on that, and I've never seen him so frustrated. So I'd be happy to share that paper with you if you send me an email. And I think we have a supplemental appendix where we talk through like the pain. Yeah, but that was the main complication, is doing a SAR. SLX is super easy. SLX you can do, super easy. I shouldn't say it like that, but I mean, like it's much easier. I'd say the SAR is an order of magnitude more complicated.
Other questions? No? It's Friday
Yes.
afternoon of a long, intense second week of the summer school. Yes?
Absolutely.
So thank you very much, Guy. We're going
Thank
to
you.
close the session and close this week with this. And I just wanted to thank you again very much.
Thank you. Thank you all for coming.
And we're really looking forward for the students that are going to be here next week. We're going to be with Guy in class. We're going to be looking at time series pooled cross-section models. So it's going to be a really fun week for us. And then I wanted to remind everyone, the week ahead is rest, have fun. I hope you have sun this weekend. But Monday, I wanted to remind everyone, we're going to have the next late afternoon seminar. So it's back-to-back because it's an intense week. So just kind of fast-forwarding to the week ahead. On Monday, we have a late afternoon seminar on gender and methods. We're going to be having an interesting panel discussion. And we're going to be posting readings because the panel will be working on and focusing on the four speakers are going to be commenting on a series of new research that's emerging on the topic. So we're going to be posting the papers on the online portal of the summer school for those of you who want to after take a look at this work. And for all the talks of the late afternoon seminar, we're also trying to post the papers so it makes it easier. So for Guy's presentation today, we're going to be posting the AJPS paper that we have. So you can, for those of you who are interested and want to see what is this research about, we'll be making it more accessible so you can take a look. And then Tuesday, Tuesday is pardon? No? We have Tuesday, Wednesday, Thursday. Thursday we're going to have, I'm skipping ahead quickly, but I'm trying to remember the schedule. But what I do remember is we have your poster session coming up, right? So for those of you who have not yet submitted a poster, we just wanted to make sure, we really want to, it's an amazing event, and we hope that you guys decide to participate. It'll be on Thursday from 12 to 2. During the poster session, we're going to provide, am I messing up the day? Because, no? Okay. I'm sleep deprived, and I'm seeing error correction co-integration at the same time in my head. So if I'm messing up the days, but this poster session is really a chance that it's now in the 4th time we've done it in the summer school, and it's something that's become incredibly important to the school because a lot of you are working on really important, interesting research, and it's a chance for you to get feedback and for us to learn more about what you're working on. Each year, the poster session has become more, it's growing in size and in terms of learning students about different topics from many, many, many different areas. So there's still room for those of you, even if your poster's not up, you're still welcome to participate if you're interested in putting together a poster. And the way that the session works is every author is going to be at their poster for the 2 hours. So the idea is, and that's why we want to really encourage everyone to attend the poster session and be there. We provide lunch, and it's going to be a good lunch, I promise. It's going to be good food. And what we want is for you guys to go around, walk around, visit different posters, get a chance to talk and interact with the authors and ask about their research. It's really important to the school. The school is about that we learn together, talking together, sharing our research, being collective in trying to advance research. So this is an opportunity in the school that we really prioritize because it's a chance for the participants to get feedback. And there will also be a faculty committee that will be going around during lunch, asking questions to the presenters. And at the end, on Friday, we'll announce who wins the prize. So we're going to have a 1st, 2nd, and 3rd placed poster on Friday that will be announced. So it's also exciting for those of you while you're going around, try to guess who's going to win, right? Okay, so we'll see you guys next week. Thank you very much for coming today, and thanks, and we'll see you next week.